All right, everybody. So for today's lab, we have seen some weathering going on and seeing how it affects the rocks. And for today, one of the processes that we saw that makes different types of rocks. So we click and analyze, we saw different types of things happening. Let's move into a little bit of a graphing lab today with our unit is, do rocks weather at the same rate? So today you're gonna have granite, which is the rocks with the little black dots on it. And then you have just marble, which is a metamorphic rock, just white. The granite is an igneous rock. That's what we also find in the Rocky Mountains. Do they weather at the same rate? Can this help us explain, help us a little more about why these rocks look different? So for our question, if you could have this open from Notability, our research question today is, do rocks weather at the same rate? Do rocks weather at the same rate? So what can we measure? Well, we can measure the rocks. With that, we have the mass. What else can we measure here? Oh, we have different objects on here, so we can definitely measure those. So, and then we can also measure so when we weather them, we're gonna be filling these up today with water and then closing it, locking it, and shaking it. So how that's gonna work is you're going to first take your vial, this one being granite. Our independent is the one thing we're changing, that's the type of rock. And then the interdependent is the mass afterwards. Our control, I would say, we need to shake it, same shake time in those vials. Maybe the same amount of water. And then for our data table, I think we can just do a T-chart again. We have marble, and we have granite. I say we should get some good data. We should shake every 3 minutes. So every 3 minutes, we will record the time. How do we collect our data? Well, if I move over to the sink, take our vial, and there is a 60, if you can see that, 60 milliliters. Let's just fill it up to 60. So with our sink, let's stop, get down eye level. Notice you can't see me, but I'm at the eye level, and actually I filled it up exactly to 60. Perfect. Lock it. You're gonna shake for 3 minutes. You're gonna keep shaking for 3 minutes. Now, how do we mass it? After you've shaken for 3 minutes, we have our electric balance. Now it says 0, but we don't want, it says 0, but we wanna make sure it doesn't read the plastic. We only wanna measure how much the rocks are. So we put it on here, and now I'm gonna hit on, off again. I take it off. You notice how it reads a negative? Because it's subtracting the plastic. Then with this rocks, after you're shaking for 3 minutes, you're going to then take your sifter over the sink, of course, dump it in, and then notice now the rocks are in here. Take them back out. You're gonna put them back in the vial. And then you're gonna put them back on the mass. I put it on the mass here. It would read 28.8. So I would write that here. Then, same thing. You're gonna fill this up to 60 milliliters of water. Again, shake for 3 minutes. Strain it again, and record the mass. So you're gonna do every 3 minutes, you stop, strain the water, and then record the mass. So fill it up 60, shake for 3 minutes, strain, and then keep remassing. So do these weather at the same time. Are they gonna keep the same mass? Interesting. And our